Dear students, in today's class, we are going to discuss runtime polymorphism. Till last class, we have discussed static polymorphism, which include function overloading and operator overloading. Now we are coming to the last type of polymorphism is runtime polymorphism. Why runtime polymorphism is required and how runtime polymorphism is achieved by virtual function. As you know, poly means many, morphism means form. Class having many form is known as your polymorphism. And how much memory you want to occupy in memory at the runtime, that will be assigned by runtime polymorphism. And here main objective is by creating one object, how you can call the multiple classes respective method. And this is also one type of overriding technique. What is overriding? Overriding means the name of the function, the return type is same in both the parent class and the child class. Overloading and overriding difference is in overloading function name is same, whereas the parameter and return type may be different. Whereas in overriding the name of the function, the return type and the parameter is same in both the classes where it is invoked. How much memory we require at the runtime, that will be achieved by the help of your runtime polymorphism. Runtime polymorphism is otherwise known as lead binding, or some extent it can be termed as dynamic binding. Hence, the definition tell runtime polymorphism is achieved when the object by the help of the object we invoke the method at the runtime instead of compile time. It is achieved by method overriding. Overloading concept is static polymorphism, overriding concept is the runtime polymorphism. What is the basic difference between the compile time polymorphism and runtime polymorphism? Function invoked at the compile time. Here in runtime polymorphism, the function or the method invoked at the runtime. Compile time polymorphism example is overloading, whereas the runtime polymorphism example is overriding, which is known as your dynamic binding. Overloading is a compile time polymorphism, whereas the overriding is a runtime polymorphism. Overloading technique is achieved by function overloading and operator overloading, whereas the overriding technique is done by the runtime polymorphism by the help of your virtual function by taking the help of the pointer. It provides faster execution because limited memory space it is taken, whereas in the runtime it executes slow because it depends upon number of value, number of object, number of iteration it is required, and hence more time is required by the runtime polymorphism in comparison to static time polymorphism. Static polymorphism is less flexible, whereas the runtime polymorphism is more flexible. Flexible means how much you require, that much you take. There is no wastage of memory in runtime polymorphism. But in static time polymorphism, you cannot increase or decrease, and memory allocation is only known at the compile time. You cannot increase or decrease. There is the chance of wastage of memory. That is not happening in the runtime polymorphism. So that is the basic difference between the overloading and overriding, or static polymorphism and a dynamic polymorphism. How dynamic polymorphism by the help of a runtime polymorphism is possible by the help of your virtual function. You see, here we have taken one parent class, that is shape, is user defined name, not predefined, and one of the method is taken void draw, it is defined virtual. Why virtual declare? If you declare virtual, what will happen? If you don't declare virtual, what will happen? Virtual void draw, the name of the method is draw method. Class rectangle, which inherit the property of the shape class, means rectangle is a child class, belongs to the shape class, and its member is how, what? There is no member. The method is draw, means the method which is defined in shape class void draw, that is there. Void draw means in parent class and the child class the method in name is same, because overriding concept suggests the name, return type and parameter is same in both the classes, in parent and child. Again, class circle extend the property of shape, means this is a hierarchical inheritance. Shape is the main class, where the rectangle and the circle, which are the two child class, belongs to the base class, and it is also having the method draw, means in all cases void draw is written, which is in parent class, that is in the child class. So what is the benefit? See, shape having a pointer object and shape having a general object. rectangle have a general object, circle having a general object. Now, in shape as a pointer object which can hold the address, first it is stores the address of itself, that is sh. If s arrowheaded draw will be given, then it will comes to the parent class draw method and drawing message will be display. Now, why arrowhead is taken? Because pointer is linked by arrowhead operator. Just like general member is interactive with the dot operator. Again, in the parent class s as a pointer object, where the address of rectangle object res is stored. If s arrowhead draw will be called, then the rectangles draw method will call, that will display drawing rectangle. Then again, in s as a parent pointer object, the child class circle object address is stored. Now, if s arrowhead draw is invoked, then circles draw method will call and drawing circle message will appear. Hence, the first is parent class message, then the two child class message. Means in one pointer object of the parent class, we can store the address of different child class object. We have not to declare any additional pointer object, and hence memory efficiency and performance will be better. If you disable virtual, then what will happen? You are calling all the child class objects, but it will only call the parent class method, because by making virtual, it will ignore which pointer objects stores the address of which child objects. But if you don't use virtual, then if you are storing the child class address, it will always call the parent class. Means in all time without virtual, it will display three messages: drawing, drawing and drawing. And hence, what is the requirement of virtual? By making virtual, by taking the parent class object address, then we can store in the parent class pointer object, we can store the address of all objects of child classes. How it is possible? You comes to your desired compiler, that is turbo compiler. Same program what I have represented, I have given here. See, shape class, the rectangle class, circle class, and same methods are gets called. If I run the program, then what will happen? Three different classes message will appear. Then if I only delete the virtual, then what will happen? In all the three times, the parent class drawing method will be called, and hence the child class will be ignored. That is the real requirement of a virtual. So, I think today's session of discussing runtime polymorphism, compile time and runtime polymorphism difference in the terms of overloading and overriding, how the virtual works for the runtime polymorphism. Having any doubt, you please make the comment. If you like the video, kindly like it. If you have not subscribed previously, kindly subscribe it. Thank you. See you in the next class.